We're going to practice drawing some Lewis dot symbols. In order to draw a Lewis dot symbol, you need to know the number of valence electrons in an atom. And for most atoms, we can get that information just by looking at the periodic table, just looking at what column each atom is in. All of the atoms in the column 1A, they all have one valence electron. Column 2A, they all have two valence electrons. And then the trend continues, 3, 4, 5, 6, 7. Things get a little weird over here. Helium only has 2 valence electrons, but everything else in this column has 8. So unless we're looking at one of the transition metals, one of the guys that's down in this area right here, we can pretty easily just draw the Lewis structure by looking at the location. So the first on this worksheet, the first atom that we're looking at is sulfur. Sulfur is in the 6th column, so that means it has 6 valence electrons. And right now, let's just write out the valence electrons. Chlorine, which is next to sulfur, that has 7 valence electrons. Titanium is in this kind of tricky area, so we're going to skip it for now, and we'll come back to it because it's kind of hard. Carbon is in the 4th column, so that's got 4. Neon is in the 8th column. Noble gases, they have 8 except for helium. Hydrogen has 1 valence electron. Calcium has 2. Sodium has 1. Aluminum, right here, it has 3. And nitrogen right here has 5. So once we know how many valence electrons we have, to draw the Lewis dot symbol, we're going to write the symbol for the element, the 1 or 2 letter symbol, and then we're going to put the put dots around the symbol to represent the number of valence electrons. So if we have 6 valence electrons, that means we're going to make 6 dots. The one rule that we have for this is that the dots are going to specifically go, so if this is our element, the dots are going to specifically go in the 12 o'clock position, the 3 o'clock position, the 6 o'clock, and the 9 o'clock position, like that. So you can't just put them wherever you want. And we are going to put 1 electron or 1 dot into each one of these positions before we start putting 2. So if we have 6 electrons like we have for sulfur, we don't want to just arrange 6 or 3 pairs of 6 electrons. Our job is to put 1 dot into each one of these 4 positions, and then the last 2 we can pair up. And when we're pairing them up, we can pair wherever we want. So we could just kind of continue with this going clockwise pattern, and we could pair like that, or we could put the pairs opposite each other if we wanted to. It really doesn't matter how you lay those out. So let's practice this again with chlorine. We have 7 dots, and we're just going to go 1, 2, 3, 4, 5, 6, 7. Most people find it easy to just start at 12 o'clock and just go clockwise. Carbon, we have 4. That's 1, 2, 3, 4. Neon has 8. That's 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen has 1. Now, typically with hydrogen, when there's 1, a lot of times we just draw that dot on the right-hand side. But honestly, it does not matter where you draw these electrons. As long as you're following the rule of not pairing any of them up until you've occupied every space, you're fine. Calcium has 2, so that's going to be 2 dots. And again, you don't have to follow any sort of, rule in terms of the order or how you go about placing these electrons. So that would be perfectly fine for calcium if you like to kind of make it symmetrical. The key here is that you have 2 dots unpaired. The only thing that would be wrong about this is if you drew the 2 dots together. You don't want to do that. So there's calcium. Sodium has 1 electron. Aluminum has 3. 1, 2, kind of made my aluminum a little low there. And nitrogen has 5. 1, 2, 3, 4, 5. So it's pretty easy. Let's talk about what we would do for something like titanium. So since this is in the transition metals area, it's not easy for us to look at the periodic table and predict how many valence electrons these have. So what we're going to do instead of that is use the electron configuration, because that's another way that we can get the number of valence electrons. And we can just look it up. Since you've done a lot of electron configuration, you can just sort of cheat-ish, it's not really cheating, and just look up the electron configuration of titanium. I don't want it to be tin. Titanium, electron configuration, there it is. It's got the noble gas abbreviation for us. It's perfect. So remember, when we're looking at valence electrons, we want to be looking at the number of electrons that are in the highest energy level. So we're focusing on the number 3 versus the number 4. The number 4 is the highest energy level. That's where our valence electrons exist. And in that 4s orbital, there are 2 valence electrons. And so that means that this guy's Lewis dot symbol is going to look like